Welcome to Casting Academy. Today our topic is micromachining. This is very important machining process in electromechanical industry and also plays a predominant role in this area. Aim of this presentation to learn about the need of micromachining, to understand the concept of micromachining, to learn the various process of micromachining, to know the applications of micromachining. And now we will discuss the concept of miniaturization. It is the ever smaller scales for mechanical, optical, and electronic products and devices. Creation of ever smaller scales for mechanical, optical, and electronic products and devices. Now you see the optimization of the product in phone. The larger phone comes to smartphone. So that is the idea behind the miniaturization. Why miniaturization? Minimize energy and material used in manufacturing, reduction of power budget, and improved accuracy and reliability, increased sensitivity, items which take up less space are more desired than items which are bigger and bulkier because they are easier to carry, easier to store, and much more convenient to use. Well, the conclusion is we want optimize our system. We do more work with the lesser space and lesser area, etc. That is the idea behind the miniaturization. Now you see the miniaturization of the pen drive. You see the pen drive, larger pen drive comes into the smaller chip one. So this is the idea behind the miniaturization. The size wise scale bottom one is useful to identify the how much the size is reduced in pen drive. Next, classified of machining of three divisions. You see the in micron values, as you know, the thousands of 1 equal to micron. You see the manufacturing methods: normal machining and precision machining, ultra machining, and atomic lattice separation. You see the equipment and machine tools. You see the normal machining we use tanning and milling machines, grinding machines, etc., lapping and honing, etc., which is the surface finish is higher. And precision machining means optical grinding machines, precision grinding, super finishing, diamond grinding, etc. Ultra finishing, ultra precisions, high precision, mask elegance, ultra precision, diamond tanning, and diffraction grating resulting machines. So atomic lattice separation means molecular beam epitaxy, ion implantation. So these are all the major machining process. Now we are in micro machining. It refers to the techniques for fabrication of 3D structures on the micrometer scale. Implies parts are made to size of 1 to 999 micrometer and used mainly for finishing purposes rather than the correcting the dimensions. Processes are also used for making micro miniature components. The term micro machining is associated with the qualities of precision and ultra precision. So micro machining means the 3D structure on the micrometer scale. This is the idea began. The term associated with the qualities of precision and ultra precision. Mathematically, micro refers to the 10 power minus 6. The range of micro would then to be the 10 power minus 7.5 to 10 power minus 4.5, or roughly 31.6 nanometer to 31.6 micrometers. So 31.6 nanometer to 31.6 micrometer. However, general acceptance considers practical smaller than 100 nanometer nanoparticles. So this is mathematically. And micro particles or particles between zero point 0.1 and 100 meter in size. Commercially available microparticles are available in wide variety of materials including ceramics, glass, polymers, metals. Microparticles encountered in daily life include pollen, sand, dust, flour, and flour, and powdered sugar. So these are all the microparticles we use, and also 31.6 to 31.6 nanometer to micrometers is the basic idea behind this fabrication technology. How we produce the micro machined parts: bulk micro machining, surface micro machining, and mold micro machining. In bulk micro machining, the process for producing 3D MEMS, mechanical electro, the system structures, older process. The basic concept is to create mechanical features by removing material from water. Bulk micro machining is done through a sequence of photo patterning steps followed by wet etching. Example: silicon cantilever beam of atomic force microscope. Silicon cantilever beam for atomic force microscope. It is suitable for creation of variety of sensor elements. And anisotropic etching of single crystal silicon. You see the dopant diffusion, masking, anisotropic etching. These are all the main etching process. So dopant, masking, anisotropic etching. Here you see the diffused layer and non-etching mask and pre-stacking cantilever. So this is a basic idea. So dopant diffusion, masking, and anisotropic etching. So this is the surface micro machining. Surface micro machining. Sorry, so next one is surface micro machining. It is the technology that enables the fabrication of a variety of actuators or motors in addition to physical and chemical sensor. Newer process for producing MEMS structures. So accelerometers, pressure sensors, and gears and transmissions, micro mirrors, etc. So these are all the surface machining category and principle. In surface machining, mechanical devices are formed by the successive deposition, photo patterning, and etching of thin films on the surface of water. This is the idea. Deposition, photo patterning, and etching of thin films on the surface of water. Two types of thin films are used: structural films and sacrificial films. Sacrificial films serves as a spacer layers between the structural levels. As a final step, they are etched away, leaving the structural levels free to move and operate. Typically, in the surface micromachining, polycrystalline silicons used as a structural material. At the end of the process, wafers are immersed in hydrofluoric acid, which quickly removes the silicon dioxide layers, leaving the structural polycrystalline silicon. This is the principle. And you see the sacrificial layer and sacrificial layer, material layer, and material layer after first etching and second etching, and finally the final etching. So this is the idea behind the etching process. And mold micro machining. In this technology, mechanical features are created by creating the mold. This mold is in the shape of the desired mechanical structure. The mold is thin, then filled with a structural material to create desired mechanical devices. The mechanical device can be removed from the mold. Then the most famous technology for mold micro machining is the liga technology. So mold micro machining, first of all creating the mold. The mold is desired mechanical structure. The mold is filled with the material and mechanical devices can be removed from the mold. The most famous technology is LIGA, bulk versus surface machining process. In surface machining process is more complex than bulk micro machining and requires more fabrication infrastructure. Bulk micro machining where comparatively larger amount of material is removed compared to surface micro machining. Surface micro machining creates structures on top of substrate. In bulk micro machining produces structures inside a substrate. So this is the comparison between the bulk and surface machining. And you see the micro machining, conventional and unconventional. In conventional process, micro tanning, micro milling, micro drilling, and unconventional EDM, electric discharge machining, chemical machining, abrasive jet machining, laser beam, electron beam, ultrasonic machining, and MAF machining. These are all the micro machining categories. Classification based on types of energy used: traditional, mechanical, and thermal, chemical, hybrid, electrical. In traditional, micro milling, micro drilling, micro tanning; mechanical, micro abrasive jet machining, micro AF abrasive fabrication, and USM ultrasonic machining; thermal, micro laser beam machining, electron beam, and micro beam machining; and chemical, electrochemical machining, hybrid, ECG, EDG, tanning, EDM, the electrical, electric discharge machining, wire cut, EDM. These are all the main classification on types of energy used. You see the micro lathe. So left one clearly, this is the case of micro lathe, headstock and everything, bed, so slide, etc. So in micro machining, micro lathe, first of all the working principle is micro lathe, which is controlled by control unit by an operator, and we view in optical microscope. So what have been done through monitor through optical microscope? That is the idea. Micro factory. Now you see the micro factory. So the case is optical microscope and monitor. Here the optical microscope and monitor. The lathe operator done the turner will done the operation through this micro optical. Next, EDM, electric discharge machining. The same is the panel, micro tool, and rotating clamp. Everything is in conventional machining, but all are in smaller, very smaller size. Equipments used: micro tanning, micro milling, micro drilling, micro EDM, micro wire EDM, micro grinding. So other names: tool, milling cutter, drill bit, electrode, EDM, wire, abrasive, etc. Micro cutting tool. Now you see the micro cutting tool, 10 micrometer tool with a human hair. So micro cutting tool is compared with a human hair. Advantages: it provides higher reliability, high resolution and aspect ratios, minimal redeposition and localized heating. There is no need to pre or post processing of materials. The availability of wide variety of materials and fully automated process. Applications: micro milling, micro grinding, inkjet printers, manufacturing of injection nozzles, micro surgical tools, VLSI circuits. Applications include MEMS devices, micro dies and molds, produce intricate medical equipments. These are the major applications in micro machining. Industrial applications of micro machining equipment. The main requirement for precision machining has focused on tighter tolerance, better surface quality, consistent part geometry, and lower total cost for a variety of uses that include new engineering materials difficult to machine. So why we go industrial applications in this area? Tighter tolerance, better surface quality, part geometry, consistent part geometry. Silicon wafers. So it is the silicon is the dominant material throughout the semiconductor industry. Silicon wafers being used extensively for the micro fabrication of integrated circuits, IC, micro sensors and micro actuators devices. The machining of silicon wafers is not noted to be an essential phase in the fabrication process. Micro machining is being increasingly used in the direct production of wafers instead of the process of grinding, lapping, polishing, since micro grinding is economically attractive and offers higher dimensional and flatness control and can yield a damage-free surface finish of high quality. So silicon wafers is the predominant role in the IC industries. So this is silicon crystal cutting and micro grinding silicon wafer. So you see the cutting from and then silicon wafers and pattern formation. So circuit. So typical fabrication process of IC devices. So first silicon crystal cutting, micro grinding in silicon wafer and furtherly dicing and device is their circuitry pattern formation. Specifications of micro machining. Wafer thickness 100 to 300 micrometer, grinding wheel, diamond cup wheel speed 3000 rpm, in feed rate 0.05 mm per minute, spark out time 0 seconds, coolant water, depth of cut zero point 0.1 micrometer, production time approximately 30 seconds. The flatness and parallelism of the wafers produced were less than 2 micrometer. So this is the specification of micro machining. So industrial applications. You see the industrial applications. First, right one is a turbine engine blade micro machined in a variety vibratory finishing machine. And left one is some micro ground silicon wafers. So these are all the idea behind the micro industrial applications products. You see the product. Micro machining process. So milling, drilling. So micro cutters. This is micro milling. So in what area we have find job for micro machining? Just you see the one by one coherent and career opportunity of micro machine, custom micro machining jobs, glass door and micro machining jobs, and laser micro machining export lasers. So micro machining employment. So please go through the carriers. So these are all the micro machining, very important because in electromechanical industry carrier is very booming. So you go through carefully and observe many things. So finally I conclude this session. Thanks for watching this PPT. And now you see the an ant will take the gear of paper gear, which one is micro machined. So I hope all you well understand about the micro machining. Thank you.